You attach two rods with hanging ornaments to the ends of a larger rod as shown in the image below. Where should you place the support wire to the top level so that all the levels of the mobile are balanced? So right now these lower levels are set up in such a way that they balance. However, on this top one, we need to find the position A, B, C, or D where we should hang the wire so that it's balanced. A lever arm like this is balanced when the moments on one side are equal to the moments on the other side of the lever arm. So what are moments? So a moment is just the mass times the distance away from the center. So if these little segments are, say, 1, we'll just say that they're 1 for sake of simplicity, then the moment is going to be 4 times 1 on this side. So here we have another distance of 1 and a mass of 1. So the moment is 1 times 1. And then the other mass is a distance of 1, 2, 3 away and has a mass of 1. So 3 times 1. 3 times 1 is 3, plus 1 is 1, equals 4. And that's true, 3 plus 1 is 4. So this side is balanced because moments on one side equal moments on the other side. We can show the same thing on this side. The moment here is going to be 6 times, and the distance here is 1, so 6 times 1. And then the other side, 3 times, and the distance from here to the center is 2. 3 times 2 is 6, and 6 times 1 is 6. So the lever is balanced. So getting back to our problem, first let's write these two lower level balances as single weights. So I'm going to take our balance here, and since in total this level's weight is 1 plus 1 plus 4, or 6, we just put a weight of 6 right there. And then over here on this right side is 3 plus 6, or 9. Let's just replace that with a weight of 9. So now we don't know where we're going to hang this rope. It could be A, B, C, or D, but I'm just going to call this distance from 6 to the fulcrum x. And then what is this length going to be in terms of x? So this whole entire length is 1, 2, 3, 4, 5. So it's going to be 5 minus this x. So now I'm just going to find the moments on this side and on this side and set them equal to each other and see what the x is going to have to be. First, the mass on this side is 6 times the distance from the fulcrum is x. And this should be equal to 9 times the distance from the fulcrum, which is 5 minus x. 6x equals, distributing the 9, we get 45 minus 9x. Let's add 9x to both sides. 6x plus 9x is 15x. And here the 9x and the minus 9x cancel each other out, and we're left with just 45. Let's divide both sides by 15. 15 here and 15 here cancel out, and we have just x. And on this side, 45 divided by 15 is 3. So our x, I suppose we drew it wrong, because really it should be a distance of 1, 2, 3, and that is mark C. So the answer to where should we hang the wire, it should be hung on mark C.